world, welcome back to another CTF After Dark Fall 2022 write-up video. In this video, we'll be walking through all the scripting challenges from the CTF. Let's get into it. We're going to start off with laws of aviation. Every night before bed, I enjoy winding down with some tea and watching my favorite movie. I've managed to memorize the entire script from memory. Okay, so you get a script1 and a script2.txt. So what you want to do is run a diff on these two files. And we can do that in command line by simply running fc script1 and then script2, like so. And then you're just going to type out what the differences are. So if you look at the comparisons, right, let's start off with the first one here. A lot of ADS, a lot of ADSF. So you're going to type F, right, because that's the difference between the two. Then the next one, you're going to notice that there's an L here. So that's going to be the next portion. And then the next one's going to be A, right, because it's spelling out flag. Then G. And then open curly brace. And then H. Then O. And then N. Then E. And then Y. And finally, closing curly brace. So your flag at the end is honey. So submit that and get your points. And let's move on to the next scripting, which is mittens. It's getting a lot colder and I don't have very good circulation. I want to wear my prettiest pair of mittens to keep my hands warm, but it has been a long while since I have last seen them. Can you help me find my mitts? All right, for this one, I have all the mittens files in here. And let's go ahead and just open all that in Notepad++. And if you look at the first one, for example, and zoom out, you're going to notice that there's kind of a string of characters that don't really follow suit with the rest of the characters that are in here, which is down here. There's just this random blank line. And if you look at another file, like this one, you'll see that there's another set of those in kind of a similar spot. And so on and so forth for each file. So what if we took all of those and stacked them together? Since this is an ASCII art challenge, it's kind of implied that we are probably comprising another ASCII art image that actually ends up being our flag. So let's go ahead and start copying all those out to a new text file. And we'll go ahead and maintain the white space that they have here. All right, so you kind of can tell that this is a little messed up, and that's because there's a duplicate set of lines in here. You'll notice that lines 3 and 4 are duplicates of each other. So what we're going to do is just get rid of one of those lines. And then that will actually comprise your flag. And we can zoom out and you might be able to see it a little bit better, but it says flag burn for you. So let's enter that in as our challenge solution here. And submit. All right, let's move on to the next scripting, which is tar pit. I found this pit of tar that's like really deep. Can you get to the bottom of it? All right, so we're gonna go to my Kali box for this one. And you'll notice that there's this pit.tgz in here. And we're just gonna do some inline bash to unzip it, well, or untar it. So what we're gonna do is we're gonna run for I in 0 to 10,000, just because we don't know how many that are in there, right? If you were to open this up, it's basically one of those like Matryoshka doll zip challenges where it's a zip and a zip and a zip and a zip. You'll see that here as it's unzipping them, the file size continuously goes down because there's just a bunch of them zipped within each other. So we just need a fast way to do this, and this inline bash will do that for us. So let's do move star to pit.7z. And the reason for this is we're going to be using P7zip or 7zip to unzip it, and it doesn't recognize the TGZ extension. So we can resolve that by simply moving the file to .7z. And I do star just to get whatever the file name is in general, because we're only going to be dealing with one file, because it'll get rid of the original file as we unzip them each time and only keep the new file. So let's do P7zip now. Tac D star, because we want to decompress whatever the new file is. And then we're going to do done, and this should work. And as you can see, the size down here, it's continuously decreasing, and eventually it'll get down to a small size that, well, eventually it'll actually error out because, you know, it's not going to recognize whatever file it is anymore. See, it'll just keep going as it is, but we can see the size is 0 now. So if we just kind of Control C out of that, we can see that we have a pit.7z, but if we run file on it, you'll know that that's actually an ASCII text file. So we can just cat that out, and there's our flag. Wow, that's pretty deep. So let's copy that, paste it in, and submit. All right, let's move on to the next scripting challenge, Xordinary Encryption. Mwahaha, you'll never find my flag. I have encrypted it so strongly that it is impossible to crack. Wait, what do you mean a single byte isn't enough? Note, the flag you find will not be surrounded by flag. Please add that before submitting. All right, so let's open this up. And it looks like it's just hex characters. So we can copy that and we can put it into CyberChef. And we can do from hex. And there's our flag. 1 in 256 are great odds. So like it said, we'll take this and we'll put it into the flag format like it wants and submit. All right, let's move on to the next scripting challenge, which is hop, skip, jump. This maze may or may not have some hidden data in it. If it did, it would have been added using this script. All right, so I have those files over here. Okay, and we have a gen.py, a maze.bin, and a solve.py. If we were to look at the maze.bin, actually I can just close that. In a hex editor, you'll see that it's just a bunch of random characters, seemingly a bunch of random characters. And if we look at gen.py to start with, we'll see that the flag is redactive, of course. We have a num bytes constant and a clock that floor divides the number of bytes by the length of the flag. And then it opens the maze.bin to write out 2. And it says for I in range of 1, 2, 3, 4, 5, if j is greater than or equal to the length of flag, break. If I mod clock equals 0, then c equals flag of j. Out.write flag of j, j plus 1, or it increments j, and then we have else, c equals the character random integer 40 to 100, and then it writes that character out. So essentially, whenever I mod clock is equal to 0, it's going to write a character of the flag to the output, or that junk that we saw in that maze.bin file. So basically, we just need to kind of perform the same process to extract those characters at those positions whenever I mod clock is equal to 0. And that's what I do in my solve script here, which I'll pull that up, and we can actually split that to the right here so we can see both scripts. So I open the maze.bin, and then I read, of course, the maze file. And then I say the clock is equal to 1, 2, 3, 4, 5, floor divided by I, right? Because when we do for I in ranges 20 to 101, we do that because the original flag was between 20 and 100 characters long. So we don't quite know what the length is. So we kind of have to try all the lengths between those two numbers. Then we do for j in range of the length of maze. We do if j is mod clock is equal to 0. Like I said, we're doing the same process to pick out the characters of the flag. Then we do flag plus equals maze at j. And then we say if flag in flag, right? And the reason why we have to check if the flag is in flag, because otherwise we'll get all the iterations up until the flag, and we just want our flag. We'll print the flag and then exit the program. Okay, so with that being said, let's go ahead and run it. And there's our flag. Never do string manipulation without Python. So let's copy that, paste it in, and submit. All right, let's move on to the final scripting challenge. Android's dream of sheep. Welcome back to my wonderful world of scripting challenges. This time, the droids have taken over and hidden some of my pages, including the flag. Please rescue my flag from the robot invasion. Okay, so let's open up the world. And since this is referring to robots, let's go to robots.txt. You'll notice there's a bunch of web pages here under a hidden directory. So we need to search for the flag in all of these web pages essentially to find out which one actually has the flag in it. Now there's a lot here, so obviously we need to automate that process. And I'll show you what did and didn't work for me in regards to that. So I actually have the script already run here because it does take a little bit to run, so that's why I already kind of pre-ran it. And I'll show you what the script looks like here in a second. But essentially I ran it and it shows you which web page actually had the flag in it, and then it prints out the flag right here. Now the scripts, I actually have two here. My original one was the solve.py script right here. And the problem with this one is it does use curl, which is, you know, a native bash tool. So I thought it would be faster, but it actually ended up being really slow, and it ran for a couple hours, still not finding the flag. It would have probably found it eventually, but it was just too dang slow, and I wanted to get this challenge done. So what I ended up doing was writing solve2, which uses the request library in Python instead, which ended up being significantly, like magnitudes faster than using the sub process with the curl command here. So this is actually the script I used to crawl through all those hidden web pages. Let's go ahead and go over both scripts real quick. We open the robots.txt, we read the lines, we define those lines as paths, and then we check output with the curl command, and we check to see if the flag is in the output. Then we print out the path as well as the output. Again, this one was too slow. I mean, if you had all the time in the world, you could have run it and just waited for it. But this is the cream of the crop right here that actually ran efficiently. And again, we just open up the robots.txt file, we read in all the lines as paths, and instead of the curl command, we do a request.get, of course appending the path to the original domain. And then we check if the flag is in the response text. Then we print the path as well as the response text, which contains the flag in it, which is what you see here. So our flag ended up being WALL-E is an excellent movie. So we'll grab that, and we'll paste it in here and submit. All right, that wraps it up for all the scripting challenges from this CTF. So if you enjoyed the video, drop a like and subscribe to the channel to show your support. Turn on post notifications to get regular injections of cyber content directly into your feed. Check out our Patreon, join our Discord, and follow us on Twitter. Links in the description box down below. And leave any feedback or questions in the comment section down below. This is Almond Milk. Thanks for watching. Goodbye, world.